In this section, we will discuss pods. Because we are discussing Kubernetes objects, so it is necessary to discuss pods at a very first place. If I talk about pods, then I would like to tell you in the beginning that all these objects finally create pods. That means the final product of a deployment is pod. The final product of a daemon set is a pod. Static pod is also a kind of pod. And when you create stateful sets, they also create pods. And separately, you can create pods itself as an object. Okay, but all these objects have different purpose in Kubernetes. That means you cannot create a deployment where you need a daemon set. You cannot create a daemon set where you need a static pod, and similarly stateful set. So the purpose of every object is different, but finally they create pods on the Kubernetes cluster. That's why it is very much necessary to understand what is a pod. So as we have understood earlier also, that if this is a container, then this is a pod. So what we do, Kubernetes does not deploy containers directly on the worker nodes. The containers are encapsulated first into a wrapper, which is known as a pod. And I told you the reason why. Because a pod is easier to handle than a container itself. Okay, the Kubernetes attach an IP address on pod level, and all the containers inside the pod can be accessed via different port numbers, but the IP will remain same. So a pod is a single instance of an application. A pod is the smallest object that you can create in Kubernetes. It is also called as the building block of Kubernetes. Any container in the same pod will share the same resources like CPU and RAM and the local network, which means the IP address. Imagine this is a 3-layer web application. There is a web server, there is a database server, and there is a messaging app, which is the part of the application itself. So if you want to deploy this application via containers, so basically every application is running inside a container. Okay, inside a container means a separate pod with its own container image as a Docker image. Okay, so we will have a separate Docker image for the web server, which might be developed into Node.js. Okay, and we will have a separate Docker image for the MongoDB for the database. Okay, and we will have a separate Docker image for the messaging app, and every image will have its own dependencies. That means libraries and binaries. Okay, any packages if are required, and these 3 containers we will create on the Kubernetes cluster and will connect them via internal network. So all these 3 pods together will be called as an application, 3-layer web application. Okay, this is just a simple explanation. It will contain more objects than simply the pods. So let's practice pods now.